Hello 20-1 students. So today we are looking at the quadratic formula. So this is our last section on solving quadratic equations, and we're going to divide this lesson into two parts. So today will be part one. So as kind of like an introduction of how we actually develop the quadratic formula, we want to remember this work of completing the square with a polynomial. So let's work through it and just remember kind of what those steps are before we look at how we get the quadratic formula. So this is our function that we're given, negative 2x squared plus 16x minus 3. And we're asked to solve it by completing the square. So remember, we always want to set our function or equation equal to 0. So the first step when we're completing the square is that we want to isolate the first two terms, and then once we've done that, if it's possible to factor something out of there, we would like to do that. So 2 can go into both, negative 2, I guess, can go into both 2 and 16, of course. So let's take that outside of the brackets. So negative 2 divided by negative 2 leaves us with positive 1, so we have x squared. 16 divided by negative 2 gives us negative 8, and then we have to keep the x there. And then we still have the minus 3 on the other side, equals 0. Okay, so now that we have this factored out, remember, this is where we start to look at the step of actually completing this square. So this would be where we want to find a value that is half of this b value, right? So it's always, this is our a value, our b value, and our c value. So we want to find a value that's half of this, and then we want to square it. So half of 8 is 4, half of negative 8 is negative 4, and if we square it, we get positive 16. So we want to minus 8x. Remember, we want to add in that 16, but we also want to subtract it because we don't want to change the actual numerical value of our equation. So minus 3 equals 0. And now what we want to do is we want to isolate our trinomial. So that's the first 3 terms here. That means we want to move this guy outside of the bracket. But remember that because this value is multiplied by negative 2, we need to do that before we move it outside the bracket. So we're going to have negative 2x squared minus 8x plus 16. And then negative 16 times negative 2 is positive 32. So we're going to do plus 32 on the outside, minus 3 equals 0. Okay, now what we want to do is make our perfect square trinomial into a binomial. And so remember that in order to do that, basically we would just find the square root of 16, which is 4, positive or negative. So we need to use the middle term to evaluate which one of those it would be. So because it's negative 8, we know that we would need to have negative 4 and negative 4 to get to negative 8. So our binomial is going to be x minus 4. And then just remember to square that bracket. And then over here we have 32 minus 3, so plus 29 is equal to 0. Now the other thing we want to do is start moving this value away so that we can get closer to solving for x. So let's move 29 to the other side. So we have negative 2x minus 4 squared equals negative 29. Then the next thing we would want to do algebraically is get rid of this 2 that's being multiplied by the bracket. So let's divide out the 2. And of course, if we do that to one side, we have to do it to the other side. So now we have x minus 4 squared equals 29 over 2. Sorry, negative 29 over 2. And then the next thing we would do is get rid of the brackets, right? And the brackets are being squared, so in order to remove those, we need to square root both sides. So now we're left with square rooting it eliminates the square. So we have x minus 4 is equal to the square root of negative 29 over 2. And now to get x alone, the only thing left to do is to remove 4 from this side. So because it's being subtracted, we need to add it to the other side. So we can say x is equal to positive 4, right, because we're adding it. And then remember, with a square root, ultimately it's always either positive or negative. So it's going to be 4 plus or minus the square root of 29 over 2. And in the initial instructions, we were told to leave it as a simplified radical. So we can always check and see, is there any way that we can reduce this fraction? No. There's no number that divides into both 29 and 2, so we can leave it as it is. Okay, so that's just a reminder of how we go through completing this square. And that's going to be important because it's going to help us to understand how the quadratic formula was developed. Okay, so if we, instead of having numbers, if we just have algebraic expressions that represent the quadratic formula, we can actually derive the quadratic formula on our own. So let's go through and do that. So we start out with this trinomial, and if we're going to complete this square, remember one of the first things we want to do is try to move the a value away, right? We want to try and just have an x squared value. So basically that's what we do here, is we're going to take all of this and divide a out of it. Okay, so a divided by a is going to be 1, so we're left with just x squared. Bx divided by a is going to be b over a times by x, and then we're going to have c over a. Now what they've done here in this procedure is they've already moved. If you remember on the page before, we moved the c value away closer to the end. In this one, they move it closer to the beginning. It doesn't really matter super much when you do it, just so long as you're aware that if you move it earlier, you're doing the same thing to that side as you are to the other side. So we're dividing the a away from the c. So here we would have c plus c over a, and then to move it to the other side of the equal sign, we have to subtract it. So we have minus ca. Okay. Let's see, what's our next step? So the next step is we want to make our perfect square trinomial, right? And so remember, the way that we do that is we need to find half of this middle value and then square it. So basically you need to have b over a x. Actually, I'm just going to not worry about the x for now. b over a. Oh, right, because we would only do the number value. So b over a divided by 2 is essentially what we want to do. Now, when you have a fraction like this, remember it's always easier to just say that you're multiplying by the reciprocal of 2. So remember, whenever you have a whole number, it's kind of secretly a fraction of that number over 1. So if we want to multiply by the reciprocal, we're doing b over a times by the reciprocal of this, which is 1 over 2. Okay. So with multiplying fractions, you just multiply straight across. So b times 1 is b, a times 2 is 2a. Okay, so now we have our half of this value, right? And then we want to square it. So basically we want to multiply it by itself. So b times by 2a. So again, multiply straight across. B times b is b squared. 2 times 2 is 4. A times a is a squared. Okay, so this is going to be our third term that's going to complete the trinomial. So we're going to have x squared plus bax stays the same, but we're going to add in this b squared over 4a squared. Now again, in this one, remember, because you want to keep the values the same, so you don't just want to add this in without balancing it out, so you would subtract the same value from this side. And what they've done here is they've basically just gone, like they've skipped that step of subtracting it from this side, because we know that eventually we're going to want to move it away anyways, because we want to keep this as our perfect square trinomial. So they've just gone ahead and said, okay, if we were subtracting b squared over 4a squared from here, it'd be the same thing as adding it to the other side. Okay, so they've just kind of combined those two steps. Okay, so now we have our trinomial. Remember, the next thing we want to do is we want to make this trinomial into a binomial that's just a squared set of brackets. So if you remember, like even on the previous page there, when we were doing this, basically you're looking for like the square root of your last value that you just came up with. So because we squared these two to come up with that value, b squared over 4a squared, we know that the two values we multiplied together are going to be the square root of that. So basically it's b over 2a. Okay, so to make this into a binomial, now we're just going to have the square root of x squared is x, and then plus the square root of b squared over 4a squared, which was b over 2a. Okay. If you were uncomfortable just like recognizing that it was those ones that we multiplied together, the other thing you can do is just square root this last term. So if you square root b squared, you end up with b. If you square root 4a squared, square root of 4 is 2, square root of a squared is a. Okay, so you still can figure that out. And then we just square those brackets. On the other side here, what's happening is we're just going to combine these terms. So we're going to start simplifying. So remember that if you have, if you're adding fractions together, you need to rationalize the denominators. So basically that means you need to have the same denominator in order to add them together. So essentially what we would do is, because this one has an a in it already, and this also has an a, this value is going to have to increase to match this one, because we don't want to ever decrease the denominator. So we're going to have to multiply a by what to make 4a squared? Well, let's see here, negative c over a. So if we want to make a into 4a squared, we would need to multiply it by 4 to make it 4a, and then by another a to make it 4a squared. Okay, so then the other thing is, if we're multiplying the bottom to make the denominator the same, we need to do the same thing to the top. So also times by 4a. Okay, and that's going to give us c times 4a gives us 4ac. And a times 4a gives us 4a squared. Okay, now that we have this value, we can add it to the other one, which was plus b squared over 4a squared. And remember that when you add two fractions that have the same denominator, you can basically combine the denominator, so we have 4a squared, and then on the top we're going to have, oh sorry, this was negative c, so I forgot to put that in there, negative 4ac plus b squared. Okay, so that's where we come up with these terms have basically combined to form this term. Okay, so now the next steps are all just about isolating this x. So if we want to isolate this x, the first thing we need to do on this side is get rid of the brackets, which are basically the exponents. And so because it's being squared, we want to square root it. Okay, so when we square root this, basically we're getting rid of those squared brackets, so we're left with what's inside. On the other side, we have the full fraction here underneath the square root sign. Now we just have x plus this b over 2a, so we need to subtract b over 2a from both sides in order to move it over. Wait a minute, let me see, what did they do here? Oh, it looks like they didn't do that yet. Oh, okay, so here, sorry, we're first going to simplify. You could simplify after, but I guess they wanted to do it first in this particular setup. So if we have this square root of negative 4ac, because you can't square root a and c, you can't square root the 4 that's attached to them either. And then we have b squared, which technically we could square root, but because this is all one term, because it's being added together, we can't isolate that one on its own. So this is going to stay the same, negative 4ac plus b squared. And for convenience sake, I guess, because people don't like to see negative signs out front maybe, they just moved it around. So instead of saying negative 4ac plus b squared, we're going to say b squared minus 4ac. And that all has to be under a square root sign. However, with this term down here, it doesn't have anything being added or subtracted, and both terms being multiplied by each other are perfect squares, so we can square root them. So the square root of 4 is going to be 2, the square root of a squared is going to be a. Okay, now what we want to do is what I was mentioning earlier, where we want to subtract this off from the other side. So we have our simplified term, and we're going to subtract off b over 2a. Okay, and again, we want to combine. So because we have the same denominators, that's fairly easy to do. So essentially what we have is this whole square root thing minus b. So basically we have a negative b sign, and remember with a radical it's always could be positive or negative for the square root. So again, they've kind of rearranged it and put the negative b out front instead, and then plus or minus the b squared minus 4ac instead of doing plus or minus b squared minus 4ac minus b. Okay, so just rearranging it so it's a little bit more straightforward. And then the bottom, the denominator stays the same as 2a. And this here is our quadratic formula. So this is what we're going to be using in this section to solve quadratic equations. Okay. And this is a nice way to solve things when it's difficult to factor or complete this square for a polynomial. So let's have a look at how we can actually use this. I'm just going to get rid of this page number here a second so we don't run out of room. Okay, so we're asked to solve 3x squared plus 5x minus 2. So what you always want to do when you're using the quadratic formula is identify a, b, and c. Okay, so and then make sure you include your positives and negatives. So a is actually positive 3, b is positive 5, and c is, with that negative sign in front of it, that's always what you keep together with the value, so c is equal to negative 2. Okay, now all we need to do is, as long as we have our quadratic formula, which you have on your formula sheet, we can just plug in our values. So x is going to be equal to negative b, so our b was positive 5, so when we make it negative, it is a negative value, plus or minus the square root of b squared, so 5 squared is 25, minus 4 times by a times by c. And then we want to divide it out by 2 times by a, which was 3. Okay, so that's going to give us, let's see, x equals negative 5 plus or minus the square root of, let's see, negative 2 times 3 is negative 6, times by 4 is negative 24, but we have minus negative 24, so it's going to be plus 24. 25 plus 24 gives us 49. So we want the square root of 49. And then 2 times 3 is 6. Okay, so let's see. They just told us to solve it. Okay, so now we want to think about what we can simplify. Square root of 49. 49 is a perfect square. So what we're going to end up with is x is equal to negative 5 plus or minus the square root of 49, which is 7, divided by 6. Okay, and so if we have negative 5 plus 7, then we have positive 2 divided by 6, which we can simplify down to 1/3. So that would be one of our possible solutions for x. If we did negative 5 minus 7, we would have negative 12. And then again over 6. So negative 12 over 6 is negative 2 over 3. Or sorry, not negative 2 over 3, negative 2 over 1. There we go. So that is negative 2 then. So our two possible roots for this equation, or two possible solutions, are positive 1/3 and negative 2. And remember what that's telling us. That's just giving us our x-intercepts for the graph that is represented by this function. Okay? All right. Now let's have a look at the discriminant. So the discriminant is basically the part that was found under the radical sign in the quadratic formula. So if you remember, here's our quadratic formula. This section right here is the the discriminant. So b squared minus 4ac. And what's particularly useful about this discriminant is that it can help us to figure out how many roots a quadratic equation has. So basically how many x-intercepts a graph will have when you graph out a quadratic equation. So let's look at the three different possibilities, which are 2 roots, 1 root, or no roots. So if you're going to have 2 roots, then the value of the discriminant is always going to be positive. So in this case, let's look at x squared plus 6x plus 3 as our example. So if we want to figure out how many roots this function has, we basically just need to do the math of b squared minus 4ac. So first we want to identify a. There's no value out here, so remember that means a is equal to positive 1. B is positive 6, and c is positive 3. Oops. Not sure why I did that one like that. I'll just leave it like that. There we go. Okay. So now we just want to solve b squared. So 6 squared is 36 minus 4 times by a, which is 1, times by c, which is 3. So basically we have 36 minus 12. And that gives us 24. So because this is a positive value that's greater than 0, there's going to be 2 distinct roots. Now, what you would usually want to do in this situation is graph it out to confirm. And I'm not going to go through the whole graphing here because it'll kind of waste your guys' time. But basically what we find is something kind of like, I think it was kind of like this, and then it went through like maybe the origin. Okay, so we have 2 different roots here. So all this is telling us is just how many roots there are. So if we have a positive value, we have 2 roots. Okay, now the next one is if you have the discriminant is equal to 0. So let's have a look at an example of that. X squared minus 6x plus 9 equals 0. And so our a value is, again, 1. B is negative 6. And c is positive 9. Okay, so solving for the discriminant, b squared, so negative 6 squared is 36 minus 4 times by a times by c. So 4 times 1 times 9 is 36. So 36 minus 36 equals 0. So 0 is going to be equal to 1 root. So basically that means the vertex of the graph is going to just touch the x-intercept. In this case, that's at 3. So again, if you were doing this on a test, I would recommend you go in and put this into your y equals on your calculator, graph it, and just confirm. And you're going to end up with something kind of like that. Okay. Now the last possibility here is that there's no roots. So this is when your value for the discriminant adds up to less than 0, so a negative value. So let's try it for x squared plus 4x plus 9 equals 0. So a is again 1, b is 4, positive 4, and c is positive 9. So b squared, 4 squared is 16 minus 4 times by a times by c. 16 minus 36 gives us negative 20. So negative value equals 0 roots. So that means that our graph never touches the x-intercept. Oh, sorry guys. Hopefully that wasn't up in your screen for too long. So negative value equals 0 roots. And so basically what your graph is going to look like for this particular one, if you put it into your calculator, is, let's see, I think it was around -2 and +5. So there was a vertex and then the graph was directed up. Now, of course, you could just as easily have a graph that would look like, you know, something like that, where it opens downwards. But again, the vertex is not going to be on the x-axis or crossing it. So we end up with 0 roots. Okay, so those are 3 possibilities for the discriminants and how they're going to indicate the nature of the roots. So let's try a couple more practice questions with that. So use the discriminant to determine the nature of the roots and then check by graphing. So again, in this one we have a equals 1, b equals -5. What you guys might want to do is, because I kind of just went over this, you might want to pause the video, see if you can go through these, and then come back and restart the video and see if your solutions are correct. Okay, so we have a equals 1, b equals -5, c equals 4. So we're going to do b squared, so -5 squared, which will give us, I'm just going to do that faster, -5 squared gives us +25, minus 4 times by a, which is 1, times by c, which is 4. So we end up with 25 minus 16, which gives us 9. So we have a positive value. So what does that mean about how many roots we have? It means we're going to have 2 roots. Okay. And so you would just go into your graphing calculator. I'll do one of these with you guys, but by now you should be pretty comfortable with your calculator where you would know how to do this. So basically you're going to go into y equals, and you're going to put in x squared minus 5x plus 4, and go to our graph. Oh, whoops, I had an old... no, that's not what I wanted. There we go. Let's do standard, should work. There we go. So you can see that we were correct. There's a positive root here and a positive root there. So it doesn't matter that they're both positive, it's just that we have 2 roots, and that's what we predicted, so it worked out. Let's have a look at this next one here. So we have a, this time we actually have a value 3, and b, well I guess 1 is a value, but you know what I mean. And then c is 4/3. Okay, so don't get scared off by the fraction, just carry on the way you normally would. So b squared is 16 minus 4 times by a, which is 3, times by c, which is 4/3, which is going to give us 16 minus... Now it's kind of up to you what you want to do at this point. You can keep it as a fraction, or you can multiply it out and see if you get a decimal. So basically you would go 4 times 3 times by bracket 4 divided by 3. And you can find that it's an even number. The other option you would have would be 4 times 3 is 12, times 4 is 48, and all of those would be over 3, because remember that technically these are fractions over 1, and so you would just multiply the tops and the bottoms, right? So we would end up with 48/3, which also gives us 16. So either one of those ways to solve that works, but we find that we end up with 16 minus 16, so we end up with 0. Remember that 0 always tells us that there is 1 root. So basically we're going to expect that this graph is just going to touch the x-intercept at 1 point, and it's going to be kind of like this if you put it into your graph. Okay, so again, you can go ahead, I'll maybe just show you really quickly about entering that into your y equals. So 3x squared plus 4x, and then plus, I would do bracket 4/3, and then you can go to your graph. And you can kind of see, if you wanted to, you can check by doing the trace, but there should just be, the minimum should be at let's see, second function trace, 0, left bound, right bound. And so you can see that there's only the one spot where y equals 0, and it's where x is negative 2/3. Okay. Last one here. So in this case, you can see that our number value is on the other side. Make sure that if you see something like this, you know that just like when you're working with any quadratic equation. Sorry guys, my microphone cut out there again. So just like when we're working with any quadratic equation, you have to set it equal to 0. So basically this -9, to move it onto this side, we need to add it back. So it's going to be 2x squared minus 8x plus 9 is what we're actually working with here. So our a value is 2, our b value is -8, and our c value is +9. Okay, so now we can fill in b squared. -8 squared is 64, minus 4 times by a, which is 2, times by c, which is 9. 64 minus 4 times 2 is 8, times 9 is 72. And so then we're going to end up with a value of -8. And remember, with any negative value, how many roots do we have? We have 0 roots. Okay, and so if you plug in, now remember when you do your y equals, you want to enter in this, the one that's set equal to 0. You can never use one that's set equal to a number value in your calculator. So if you enter this in, you're going to find that you're going to get a graph that looks kind of like something like that, except for way more nice looking. But that's the general idea of the shape. Okay, so go into your calculator and confirm, and we can see that the vertex is above the x-axis, so we have 0 roots. Okay, let's see here, what do we all have left? 2 more, okay. So in this one it says determine the roots for each quadratic equation. Express your answers to the nearest hundredth. So in this case, we're not leaving them as fractions or radicals. We want to simplify right down into a decimal. So if in this case, it's not asking us for how many roots or the nature of the roots. We actually have to determine the roots. So that means solving for x. And so what we want to do is just go ahead and plug in the quadratic equation. So remember, x is equal to -b plus or minus the square root of b squared minus 4ac. And this is on your data sheet, so you don't have to have it memorized, but honestly, you'll probably work with it enough that you will get to have it memorized. Okay, so x equals these values. So we just want to plug it in. So our a value is 5. Our b value is -7. So remember to keep the value in there. And our c value is -1. Okay, so plugging in those numbers, -b, so if b is already a negative value, you're multiplying it by a negative to make it positive. So we end up with 7 plus or minus the square root of b squared. So -7 squared is going to be 49 minus 4 times by 5 times by -1. Square root that and divide it by 2 times by a, which is 5, so that's going to give us 10. So now we're going to have 7 plus or minus the square root of 49 minus 4 times 5 is 20, and then times by -1 gives us -20. So 49 minus -20 is 49 plus 20, which is 69. And then divide it by 10. So now when we're giving to the nearest hundredth, that means we need to round to 2 decimal places. So basically in your calculator, you just want to go, for me, I just find the square root first. So I have the number there, and then I would go 7 plus that value divided by 10. Gives me 1.53. So to the nearest hundredth, I can say x equals 1.53. And then the other answer, the other root, is going to be 7 minus the square root of 69, which was that 8.3. Enter that, and then divide it by 10. So that gives me negative 0.13. Negative 0.13. So those are my roots. Okay. Next one, it's said to do the same thing. Now with this one, because we have a fraction value for our a value, you could work with it, but personally I prefer to simplify because both of these fractions are the same denominator. We know that we can eliminate them by multiplying by that value. So essentially we can go 2 times by t squared over 2 minus t minus 5 over 2 equals, now if we're doing this to eliminate the denominators to all of the values on this side, that means we have to do it to the other side as well. So 0 multiplied by 2 on the other side. So 2 times by t squared over 2 eliminates the 2, so we're left with t squared. 2 times by negative t gives us negative 2t. 2 times by negative 5 over 2, again, just eliminates the 2. So we have minus 5. And then 0 times by 2 is still just 0. So now we have a bit of an easier set of values to work with. A is equal to 1. B is equal to negative 2. And C is equal to negative 5. So now, if we just plug in, x equals negative b, so remember negative times by negative 2 gives us positive 2. Always remembering to multiply those negatives out properly, otherwise you will end up with incorrect values. So plus or minus the square root of b squared, so negative 2 squared is 4, minus 4 times by a times by c, and all of that is over 2 times a, which is 2 times 1, so that's just 2. Okay, and so that gives us 2 plus or minus the square root of 4 times 1 is 4, times by negative 5 is negative 20. 4 minus negative 20 is the same as saying 4 plus 20, so we're looking at the square root of 24 divided by 2. Okay, and then we again just need to figure out our number values in decimal form, which is what they asked us for. So we're going to go square root of 24, and then we want to do 2 plus that value divided by 2. So we have one root is x equals 3.45. Right, so just make sure that you're rounding up because of that 9 there. And then the other one was going to be 2 minus the square root of 24, so that 4.8 value, and then divide by 2. Gives us negative 1.4, and again we're going to have to round that up, so negative 1.45. So those are our 2 roots in this case. All right. Now, last question. With this one, what I would recommend, so it says solve by a bunch of different ways. Now, personally, what I found is that factoring and completing this square, you spend a lot of time trying to figure out how to move things around, especially with like the factoring and even the completing the square. It was just kind of a pain. So for me personally, now it's up to you, and it even says down here, explain which method you prefer. Different people are going to be different. For me, a lot of times when I see something and I recognize right off the bat it's not like a perfect square, it's not going to be a super easy factor, you know, there's a number value in front of the x, my tendency is just to jump to the quadratic formula because it's basically just plugging in numbers. However, make sure that for any question you still can do the other methods if it's possible, and the reason for that is because you do have to know all of these different methods, even if the quadratic formula is the easiest way to do it. The nice thing is you can always, if you have to do another method on a test, if you're asked for that, you can always confirm your answer using the quadratic formula or graphing on the calculator. Those are probably the 2 most simple ones. So basically here we would say a is equal to 6, b is equal to negative 14, and c is equal to 8. And then I would just plug it in. So negative b is negative times by negative 14, so positive 14, plus or minus the square root of b squared. So 14 squared is 196. minus 4 times by a, which is 6, times by c, which is 8. And we're going to square root that, and then divide it by 2 times a. So 2 times 6 is 12. Okay. Simplifying that, we have 14 plus or minus 4 times by 6 is 24, times by 8 is 192. So 196 minus 192 gives us 4. And we're dividing all that by 12. Can we simplify that further? Yes, square root of 4 is 2. So we have 14 plus or minus 2 divided by 12. So then we have 14 plus 2 is 16 over 12. Can we simplify that down? Let's try leaving it in a fraction. 4 goes into 16 4 times and into 12 3 times. So that's 1 root. Then the other option we had was 14 minus 2, which is 12 over 12, which simplifies down to 1. So those are our 2 possible roots. Now, a lot of times it's good if you can work with your fractions. So if you struggle with that, maybe practice a little bit, because a lot of times you're asked to leave your answer in the exact value or exact solution, not as a decimal. So you have to be able to simplify it as much as possible, because you will have marks taken off on a test if you don't simplify your fraction. Okay, so make sure you're aware of that. All right. So you guys have a practice assignment to work on for that kind of introduction to quadratic formula, and next time we will continue on with the lesson by looking at slightly more complex, like word questions. So I will see you then.